Hi everyone, so today we're going to talk about titrations. So what you are going to need is your notebook, something to write with, your reference table, and a calculator. We're going to start with a little bit of review with a do now. We're going to talk about what titration is and how to solve a titration problem, and we're going to do a couple practice problems together. First, what I would like you to do is write out the products for this neutralization reaction. Once you have the products, also balance the overall equation. Just a quick recap, right here we have calcium hydroxide. Again, if it has an OH in it, it is a base, plus sulfuric acid. If something starts with an H, like so, you have an acid, a base plus an acid, and a neutralization reaction is going to make salt water. Here is the overall balanced equation. So again, we have a base plus an acid makes water. This is a double replacement reaction, so the H is swapping with the calcium. When those switch, we have HOH. You could also write this H2O, either way. Plus the salt, so we have calcium with a +2 charge. Sulfate from table E with a -2 charge. You crisscross and reduce, and here is our salt. Which of the following is the most acidic pH? Again, pH scale goes from 0 to 14, 0 through 6 being acidic, 7 being neutral, 8 through 14 being basic. Out of the options here, D is the correct answer. A pH of 1 is the most acidic. So our new topic is titration. Titration is a method that we use in lab to figure out the concentration of an unknown acid or base. So you've collected a sample of an acid or a base and you need to figure out the concentration. This is how you would do it. So again, titration, here's your definition: adding an acid or a base of known concentration to an acid or a base of unknown concentration and forcing a neutralization reaction. Because we know what a neutralization reaction produces, aka water and salt, we know that the pH at the end of a neutralization reaction should be 7. So we are able to mix that unknown acid or base with our known acid or base until it reaches a pH of 7. There's a couple ways to monitor this. We could use a pH probe, and we can also use indicators that change color around a pH of 7 to figure out when we've reached the neutralization point. A couple of terms that you also need to know. Equivalence point. So when there's an equal amount of acid and base, you've reached the equivalence point. This is exactly when we have a pH of 7 and we've precisely neutralized the acid or a base. The other term you need to know is endpoint. So the endpoint is when you're using an indicator and the indicator actually changes color. When you get that slight color change, this is when you should stop titrating. You'll be able to see this in the lab for this week. Here we have a titration setup. I would like for you to copy this into your notebook. So what we have is a burette. The burette is going to have, in this case, the base of known concentration. So this is what we know everything about. We know the concentration. We're going to know the exact volume that we're using. And here we have the stopcock. This is what allows you to turn the burette on and off. In our Erlenmeyer flask, we have an acid of unknown concentration. And in this case, the indicator being used would be phenolphthalein because it's turned pink. But this is the general setup that you have to use. So again, you keep your unknown in one container, your known in the other, and you mix them until you reach that equivalence point, which is indicated using an indicator. The titration equation we're going to use to solve for finding that unknown concentration is on the back of your reference table, table T. So titration, here's our equation, Ma. So M standing for molarity, Remember, molarity is moles over liters. It's our concentration of acid. VA, volume of acid, equals MB, molarity of the base. VB, volume of the base. This is also super useful because look at this. Your reference table is telling you that an acid is related to protons. Your base is related to hydroxide ions. So if you forget, it is technically in your reference table. So again, this is on table T, and when we're using this equation, you are going to be given 3 of the variables. So there's always going to be one unknown. Again, this is usually going to be either molarity of the base or molarity of the acid, depending on which one is the unknown. Again, concentration is in molarity. Molarity is moles per liter, which you can also see on table T. Here is our first example. I would like you to write down the example. But if 50 milliliters of 1 molar NaOH, sodium hydroxide solution, is needed to exactly neutralize 10 milliliters of hydrochloric acid solution, the molarity of the hydrochloric acid is. So this is straight off the Regents. It was a multiple choice question, but we're going to solve together. So first, let's look at our variables here. We have 50 milliliters of 1 molar sodium hydroxide. So again, it's important that you know how to identify your acid and your base. Sodium hydroxide, it has the OH at the end. That is our base. So 50 milliliters, this is BB. 1 molar, this is MB. And we are neutralizing 10 milliliters of hydrochloric acid. So we have VA, and we are looking for MA. So this might look like a lot to look at, but let's take it one piece at a time. So the first thing I know is we're causing a neutralization reaction. We're missing the concentration of our acid. This is a titration equation problem. So you would go to table T, find your titration equation, and we're going to figure out our variables. So like we just said, the molarity of the base is 1 molar. The volume is 50 milliliters. We're looking for the concentration of the acid, and we have 10 milliliters of hydrochloric acid. Step number 2 is to plug in your values. A couple words of caution. The concentration needs to be the same on both sides, so in this case it's going to be molarity. And your volumes need to be in the same unit. In this case it's milliliters. It doesn't matter what units you're using, it just has to be the same on both sides of the equation. We're then going to plug into our equation, so MAVA equals MBVB. We're solving for MA times 10 equals 1 molar times 50, and we're going to solve by dividing by 10 on both sides, and we find that the concentration of the unknown acid was 5 molar, and that would be your answer. Here is another example of a titration equation from the Regents. So given the following titration data, we have volume of a base, it's 40 milliliters, molarity of a base is 0.2 molar, and the volume of acid added is 20 milliliters. The concentration of hydrochloric acid required for the acid to neutralize the base is what? So again, we're looking for MA in this case. Here we go, same thing. We're looking for the molarity of an unknown acid, so we're going to use the titration equation from table T, and we're going to figure out our variables, which were already listed out for us. VB is 40 milliliters, MB is 0.2 molar, VA is 20 milliliters, and we're solving for MA again. Plug in the values and make sure the units are the same on both sides, so MA times 20 equals 0.2 times 40. And then we're going to solve for the missing variable. So what I did was I combined this side, 0.2 times 40 is 8. And then I divided both sides by 20 to get MA by itself. MA equals 0.4 molar. Now I would like you to try. So how many milliliters of 0.2 molar potassium hydroxide solution are needed to exactly neutralize 20 milliliters of a 0.5 molar hydrochloric acid solution? Go ahead and try this. And here's the solution worked out for that problem. So we have potassium hydroxide, our base. The molarity was 0.2 molar. We're looking for the volume of base needed. Hydrochloric acid, we know, has a 0.5 molar concentration, and we use 20 milliliters of acid. So again, step 1 is get the titration equation from the reference table, figure out your variables. Step 2, plug into the equation. So we have 0.5 molar times 20 equals 0.2 times the volume of the base. Divide both sides by 0.2 to get the volume of the base by itself, and we find we need 50 milliliters of the base. If you have any questions, please let me know, but there is practice questions based on this lesson.